This lecture is about doing analysis of variance, ANOVA, uh, while taking into consideration blocks, meaning that you're going to have dependent groups. So the first thing I'm going to do is going back to this map. This is where you're going to have 3 or more groups. The grouping variable, remember, this is your independent variable. Your outcome variable is numerical, so you're interested in comparing averages. But this time, the members inside every group are related. For example, it's the same person that you're looking at every time in different groups. So, like we went from the independent t-test to the pair t-test, and we went from the Pearson chi-square to the McNemar chi-square. In this situation, we're going to go from the ANOVA, analysis of variance f-test. It is still in ANOVA, an analysis of variance f-test, but we have to account for something called blocks, where blocks is nothing but pairs of more than 2. So when you have pairing that has more than 2 values, you cannot call it pairs anymore, so you have to call them blocks. So how does it work? If you remember, in the previous videos, we have discussed how ANOVA works. And the idea was, let's suppose you have 3 groups, group 1, group 2, and group 3. And we said what you have to do is you have to calculate how much variability there is within every group. Okay, so that is your sum of square within. Okay, and then we talked about calculating how much variability there is between the groups, and that was the sum of square between the groups. Okay, and we figured out that these two together, if you were to add these two together, these two actually give you the sum of square total. Sum of square total, this is when you actually ignore the grouping, you just put everybody together, okay, and you want to calculate the sum of square, you get the sum of square total. So what we're going to do here is very similar. The sum of square is still the same thing. The between is still the same, it's not changing. So only the within, we're going to work on it so that it gets split into 2 sources. One is going to be the sum of square blocks, يعني الpairs, يعني individuals, and the other one is the sum of square whatever is left out, so we call it the residual sum of square. Okay, so what is the sum of square blocks? This is when you have blocking. One of the situation is when you have the same person. So you have the same person measured first time, second time, third time, and then you have person number 2 that is measured first time, second time, third time, and then you have person number 3 measured first time, second time, third time. Okay, so what's going to happen is the same way that we had actually between the groups. Remember, these were group 1, group 2, group 3. We calculated the average of group 1, the average of group 2, the average of group 3, and we saw how much variability there is with regard to the average of the averages. Okay, we're going to do the same thing. You're going to calculate the average of person 1, or I should start calling it block 1, the average of block 2, the average of block 3, and you're going to see how much variability there is between the blocks. Yani, what you're going to do is you're going to say, okay, let's say this is the average of person 1, so average of block 1. You're going to take it minus the average of the averages. Okay, you square because it's a sum of square, and you're going to multiply it by the number of times this person was observed. So 1 time, 2 times, 3 times. And again, just to stress the idea that this is exactly what you did for the between. For the between, you took the average of a group A minus the average of the averages. You squared that difference, and then you multiplied by the number of observation you had in group A. Okay, so it's going to be exactly the same way. So let's recap quickly. When you have a blocking, yani still you have group 1, group 2, group 3, or 4, or 5, or 6, it doesn't matter. But this time you have some sort of a blocking inside the groups. يعني لنقول it's the same person measured every time. Okay, so maybe it's لنقول سوسن is measured first time, second time, third time. بعدين عندنا خليل is measured first time, second time, third time. Okay, so you can calculate an average for Sausan, you can calculate an average for Khalil. Okay, these averages are going to be your block averages. مثل ما the average of group 1 is your average of the block of the groups. Okay, so recap. If you have this scenario, you can calculate the sum of square total the way we used to do it. يعني يا أما you have the standard deviation, or you just ignore the grouping and the blocking. You just take every value minus the average of the average square plus a second value, etc. You get the sum of square total. That sum of square total gets to be split between, and the between is done exactly the same way. Nothing happened to it. Okay, and within. بس هلا, since we have a blocks, we're not going to use within. We're actually going to split the within into two parts. One part is going to go to block, and we just explained how we calculate block. The exact same way you calculate between, you calculate blocks. Okay, so average minus the average of the average square times the number of observation per block, يلي هو بيطلع the number of groups actually. Okay, and whatever is left out is going to be a residual. Now I'm not going to go over how to calculate the residual because it's complicated. So what you have to do in this course, either you calculate the between, you calculate the block, and you calculate the total, and out of this you figure out the residual, or you calculate the within, which you're not going to use, and after calculating the within you calculate the block, and whatever that left out from the within goes to residual. Okay, so let's do a quick recap of how this is done, and then we're ready for the lecture. Okay, so let's say you have, okay, so you have a drug A, you have a drug B, you have a drug C, so 3 drugs, let's say 4 drugs. Okay, and you were able to get Walid, Karim, and Farah. And Walid is measured 3 times. So I know Walid the first time, the second time, the third time, the fourth time. You have Karim measured 3 times, and you have Farah measured 3 times. Okay, the table that we need to set up is the usual ANOVA table, which is the source, the sum of squares, the degrees of freedom, the mean sum of squares, and then obviously the F. Okay, now the between, we know how to do it, so the between is the same. However, we're going to start calling the between, when we're doing ANOVA with blocks, we're going to start calling it the treatment. How is it? Let's just calling it differently. Okay, then whatever used to be the within, as we said previously, it's going to be split into 2. So you have part that goes to block, and part is going to go for residual, and whatever left out is the total. Okay. So we covered the formulas, how to calculate these. In the lecture, we're going to go over that more specifically. But remember, the whole together, the sum of square of blocks and residual together are exactly equal to what we did previously for the within. For the degrees of freedom, the total hasn't changed, it's n minus 1. The block, the between, or what we now call treatment, has a change, number of groups minus 1. So 1, 2, 3, 4. So it's k minus 1. Okay. Now, within used to be n minus k, if you remember. Now, this also is going to be split, part for blocks and part for residual. The one that goes for block is exactly the same rationale, is how many blocks you have minus 1. So number of block is b minus 1. So in this situation, how many blocks do we have? Well, one block for Walid, one block for Karim, one block for Farah. So it's 3 minus 1, it's 2. And multiplying these two together gets you the residual. So it's K minus 1 times B minus 1. And if you do the calculation, that plus this actually will get you to the total. And now you're done, because you know that every time you're going to see a mean sum of square as the sum of square, you see its own degrees of freedom. You're going to divide it to get the mean sum of square treatment. So it's nothing but the sum of square treatment divided by k minus 1. For block, it's going to be the sum of square block divided by its own degrees of freedom. And for the residual, it's going to be the sum of square residual divided by its own degrees of freedom, اللي هي k minus 1 into b minus 1. Now the trick is, طيب, which one do we use to calculate the f? You're going to take the treatment sum of square, mean sum of square, and you're going to divide by the lowest one, which is the residual. Okay? So if you take the mean sum of square of treatment and you divide it by the mean sum of square residual, that will get you the F test to test if there is a difference between the blocks. Okay, so answering the research question, is there a difference between a group, I should have said, I'm sorry. So if taking the treatment mean sum of square, you divide by the residual mean sum of square, that is helping you answer the research question, is there a difference between the groups? Okay, and it has the following degrees of freedom since you use the treatment, so it's this as a numerator and that as denominator, and you can stop here. If you're interested in knowing if there is a difference between the blocks, يعني هل يا ترى I can conclude that Walid has a different score than Karim, that is different from Farah. Your research question is now no longer addressing if there is difference between the groups. You would be asking, is there a difference between the blocks, which usually we're not interested in. But in case you want to do something like that, you can. You take the mean sum of square of the blocks and you divide it by the mean sum of square of residual. That will give you the F for comparing the blocks for this degrees of freedom as a numerator and that degrees of freedom as denominator. And you would be answering a different research question. But as I said, usually we're not interested in testing the blocks. We're just interested in testing the groups. Okay, so if you understood the previous lecture, this is going to be not hard. It's just going to be easy. It's just about calculating the blocks and figuring out the residual. So let's go to the lecture and go over the lecture quickly. All right. So ANOVA for block data. This is just saying that in the t-test, we used the per t-test when the groups were independent. In ANOVA, we use something called the blocking. Okay, in some books this is called the completely randomized block, CRB, but you don't have to know that. That's just some book language. All right. Same person measured 3 times, then the 3 measures of that specific person constitute a block. So that's a definition of a block. Study looking at blood pressure under group A, B, and C, but this time there is a blocking by age. So this is just me saying that you do not have blocked by the same person. You can block by something else, as long as you have some way to match between them. But as I said previously, in our course, we're always going to use a pairing or a blocking where it's the same person. Okay. So here's an example. I'm looking at a certain maybe it's a hormone or something like that, and I'm looking at it in the morning and noon and evening. So I want to see if it changes through the day, but I'm going to use the same people. So I have Danny measured in the morning and noon in the evening. I have Zena measured in the morning and noon and evening, etc. Last person is Maya. Kamen, I measured her in the morning, in the noon, and the evening, and you can see that I have the averages per group. So the group here is morning, noon, evening, and the blocks is Danny, Zena, and I also calculated the average of the blocks. Okay. So the sum of square total is done the same way we did it for the previous ANOVA. The between is done the same way, but this time we're going to call it treatment. Okay. The sum of square within gets to be split into two parts, as I told you. Some of that is going to go to the blocks, okay, and some of it is going to do the residual, is whatever is left out. So with the sum of square within is sum of square blocks plus sum of square residual. The blocks is done the exactly same way we did between, and you're going to take the average of a block 1 of person 1 minus the averages of the averages, you square, and you multiply by the number of person 1 was observed. Well, obviously, person 1 is observed the number of groups there is, and therefore it's multiplied by k, where k is the number of groups. You do that for all the blocks, and that gives you the sum of square blocks, and therefore you can find the sum of square residual by taking the sum of square within minus the sum of square blocks. The degrees of freedom for within also gets to be split between blocks and residual. So the sum of square blocks is the number of blocks minus 1. The sum of square residual, as I told you, it's the degrees of freedom. Sorry, I'm saying sum of square, it's block. Degrees of freedom. So degrees of freedom blocks is number of blocks minus 1. Degrees of freedom residual is the degrees of freedom blocks times the degrees of freedom treatment. Remember, treatment is between. So that means that it's b minus 1 times k minus 1. You do the calculation, you figure out it's bk minus b minus k plus 1. And just notice that if you were to take the blocks degrees of freedom, يلي هي b minus 1, and if you were to add to it the residual, you're going to get the n minus k, which is the within degrees of freedom as predicted. Okay, and therefore your ANOVA table is still set up kind of the same way. So you have the source, you have the sum of square, the degrees of freedom, the mean sum of square. Remember, mean sum of square is variance, but we call it mean sum of square. And then the F. What used to be between a group is now called treatment, done exactly the same way. The residual is split between blocks. Sorry, the within is split between blocks and residual, and the total. You put your sum of squares, you put your degrees of freedom, you divide the sum of square by the degrees of freedom, you get the mean sum of square for each of the three. And as I mentioned in the introduction, the main F is taking the mean sum of square for treatment, dividing it by the residual. That's the one you're interested in. Okay, and here you have a definition. So K is number of group, B is number of blocks, N is the total sample size, etc. Okay. So the F critical works the same way, but the degrees of freedom, you have to watch out that the degrees of freedom have changed than without. And I'm also mentioning that you can also do the F for block, where you'll be testing as all the blocks are different, but as I said, this is not usually something that is interesting. So here's an example. Let's say a researcher is interested in knowing in which type of exercise the heart beats the fastest. To answer her question, she enrolled with the help of 4 volunteers and asked them each to run, to jump, to box for 15 times, 15 minutes each time, and recorded their heartbeat. Okay, so you have the data here. Running, jumping, boxing, these are the different groups. This is my independent variable. I have 3 independent variable. My outcome is a heartbeat. It's numerical, but I'm using the same people. I'm using Sausan, Nohad, Mazen, and Dina. These are the same people. So it's going to be ANOVA with blocks. I've calculated the numbers or the heartbeat. Sausan 3 times, for Nohad 3 times, Mazen 3 times, and Dina 3 times. I have the average for running, for jumping, for boxing, and I have the average for Sausan, for Nuhad, for Mazen, and for Dina. And I have the average of the averages. Okay, so we will get back to the 7th step, but for now, let's calculate the sum of square. Sum of square, the average of the average is 112.75. The SS total is 1,296.25. So how did I get to this 1,296? Either, let's go back one slide. Either I've provided you with the standard deviation of all these observations, or you have to do it the long way. يعني 118 minus 112.75 square plus 115 minus 112.75 square. So you do it for every of these 12 observation to be able to get the sum of square total. For the treatment, we said we do it exactly the same way we used to do it for blocking. You're gonna take the average of the first group اللي هو يمكن was running minus the average of the averages square, and you multiply by 4. ليش 4? Because we had 4 observation for running. Then you take the average for jumping minus the average of the averages, you square, you multiply by 4 again because we had 4 observation in jumping. You take the average of boxing minus the average of the averages, you square, and you multiply by 4, and that gets you 806. Remember 806, this is the between a group, but now we start calling it the treatment. Now for the block, with same exact approach, but this time I'm going to take the average for Sausan minus the average of the averages, square times 3. ليش 3? Because Sausan was observed 3 times. Then I move to Nuhad's average minus the average of the averages square times 3. كمان Nuhad was observed 3 times. Then I go to Mazen minus the average of the averages square times 3. And I finish with Dina minus the average of the averages square times 3. And that gets me 308. So now how many sum of squares I have? And the total and the treatment and the blocks. By doing a simple subtraction, I can calculate the sum of square residual to be 182. Okay. So this is just saying that if I were to add the within with residual is nothing but within minus a block. Okay. And so if I were to take the sum of square within, if I were to do the within, which I could do the within, okay, so the way I've shown you previously, you will get 490.25 للwithin. Remember, we don't really want the within, يعني within running plus within jumping plus within boxing. You add them up, you get 490.25. This is just to show you that if you were to take the 490.25 اللي هي within minus the blocks اللي هي 308.25, you still get 182, which is the exact same answer we're getting previously. Okay. Degrees of freedom for treatment. How many groups I used to have, or I had in this example? Well, it's 3 exercise, minus 1, so it's 2. How many blocks? I had 4 volunteers, minus 1 is 3. For the residual is nothing but 2 times 3 is 6. And notice that 2 plus 3 plus 6 gets you 11, which is the total degrees of freedom. All right, so here's the steps. The mean of mean for heart rate running equal mean heart rate jumping equal mean heart rate boxing. At least one of the mean is different from the others. We assume the null is true. We set alpha at 5%. We assume the distribution has a normal distribution and all the variances are equal. And then we set up the table. So we calculated these values a minute ago. We calculate degrees of freedom. And then all we have to do is just divide the sum of square by the degrees of freedom to get the mean sum of squares. And the mean sum of square treatment, mean sum of square blocks, mean sum of square residual. I take the mean sum of square treatment, I divide it by the mean sum of square residual, and that gives me an F of 13.28. This is called the calculated F. It has degrees of freedom numerator 2 and denominator 6. It has to be compared to the critical F. So here's my F table. There's the 2 and there's the 6. So 2 for numerator and 6 for denominator. My F critical is 5.14. Okay, so the F critical is 5.13. The F calculated is 13.28. The calculated, I observed, is larger than the critical. This means the p-value is less than alpha, and therefore you're going to reject the null hypothesis. Rejecting the null hypothesis is your statistical conclusion, and you're going to say that we have evidence that the heart rate during the different exercises is not the same. The differences in heart rates are statistically significant, and we can say that at least the heart rate during jumping appears to be higher than during boxing. And that covers the ANOVA for with blocking, and you have the same individual that are observed in every group.